That was just added to it. Congratulations. All right. So it says quadrilateral W, X, Y, Z, W, Z, and X, Y are congruent and parallel. So W, X, Y, Z. Let's just draw a picture of it. Okay. I just want to draw a picture. That's what I want. Okay. So I have W, X, Y, Z. It says W, which sides? W, Z, and X, Y are congruent and parallel. Since they're congruent and parallel, what kind of shape does this have to be? It must be a parallelogram. Okay. So then it says, what other information which is not necessarily true? Angle Y plus angle W equals 180. Angle Y plus angle W is 180. Is that true? Not necessarily. Okay. And that's our answer. So which one is not necessarily true? That is not necessarily true. It does conclude WX does have to be congruent to ZY? Yes, because it's a parallelogram. That must be true. Angle X congruent to angle Z? Yes, because it's a parallelogram. WX is congruent to ZY? Yes. Or parallel to ZY? Yes, because it's a parallelogram. The only one that's not necessarily true is a pair of opposite angles adds up to 180. Okay? But without the picture, it's pretty hard to picture, wait a minute, which one is the angle W, which one is angle X. That's why the picture really makes a difference. Yeah. Yeah. We're done with that one. 16, we have the parallelogram. So we can go ahead and just use the same picture here. With a diagonal drawn in. And we had this angle was congruent to this angle. And this angle is congruent to this angle. How am I going to prove that's a parallelogram? What's my plan? Yes. Yes, the Z's. Exactly. Okay. These angles show that these two sides are parallel. These angles show that these two sides are parallel. Both pairs of opposite sides are parallel. That must be a parallelogram. That's what you'd have to do, yeah. Yeah, they named the points A, B, C, D, so let's do that. Honestly, for me, the easiest way to do it is standard two-column format. Not a full formal proof, but just that's a nice way of doing it. So I'd say that angle ABC is congruent to ABD, excuse me, is congruent to angle CDB. That's given. So that means AB is parallel to CD by alternate interior angles. Technically converse, but this isn't a formal proof, so if you left the converse off, just saying alternate interior angles is the reason why would be fine. Then we do the same thing with the other pair of angles. Angle ADB is congruent to angle DBC. I'm sorry, ADB, DB, yes. C, given. So that means AD is parallel to BC, alternate interior angles. Converse. And so therefore, ABCD is a parallelogram. Both pairs of opposite sides. Parallel. So two-column format kind of comes back. It's not required to do it that way, and it's not a formal proof, but it kind of helps explain what's going on in a way that you're somewhat familiar with. Yes? Hold on. Sure. How would you say the two triangles are congruent? I guess you go angle side angle, right? So, but you'd still have to say that I guess you'd say a triangle is congruent by angle side angle, and corresponding parts are congruent, and then opposite sides are congruent. It'd be about the same amount of work, but that would work as well. It's a different way. Yeah, that would work. Should go with that. I don't know, I see those alternate interior and I just go straight for parallel lines. Yeah, I love parallel lines, they're fun. But yes, you could have said triangle ABD is congruent to triangle CDB because of ASA. And then AB and CD are corresponding sides, so they're congruent. AD and CB are corresponding sides, so they're congruent. Therefore, opposite sides congruent. Therefore, it's a parallelogram. Different way, but still we're just as valid. These are more, again, not really what the focus of this unit is as far as proof. Proof is not the big deal. It's just kind of an idea of seeing it again. How do we logically argue something? Yeah. Yeah, or you could, add the 2 divided by 360 and then divide that by 2. Yes. Or you could say 66 and x have to add up to 180 is also that would work. Either way. Other questions? Well, let's look at today. We have 3 basic formulas we're going to be dealing with in the coordinate plane. We've talked about these for ages. But like I said, distance formula is just one of those things that people seem to not want to get into their heads for some reason or another. Not sure why. That's the way it goes. Distance formula, which is given up here. If I'm working the coordinates plane and I want to use a distance formula on sides, what am I proving when I'm doing distance formula? That sides are congruent, yes. If I want to show that 2 things are congruent in the coordinate plane, that means have the same length. The way to do that is with distance formula, to measure their length, right? Because that's what distance formula measures, is distance or length. Slope formula is another one we're going to use. And what can I prove with the slope formula? I can prove that sides are parallel or, yes. With the slope formula, I can prove parallel and or perpendicular between any given pair of sides by finding their slopes. If they have the same slope, they're parallel. The slopes are negative reciprocals, they're perpendicular. The third one is the midpoint formula. I apologize for the yawns. Midpoint formula. So, what does the midpoint formula show us? What do we find when we use the midpoint formula? Okay, why would the midpoint formula give us slope? Wouldn't we use the slope formula to find slope? Okay, but what are we really finding when we're using the midpoint formula? We're finding midpoints, right? That's why it's called the midpoint formula. And with that, once we find midpoints, we can show if things bisect each other. That happens when they have the same midpoint. Okay? So basically, we have these three formulas we use in the coordinate plane, and that's all we're doing for the homework today is working in the coordinate plane and using these formulas. So you have to know these formulas. You have to be able to apply these formulas. Am I finding the midpoints of sides of a quadrilateral? What do I find the midpoints of a quadrilateral when I'm measuring midpoints? Do I care about the midpoints of the sides? What do I want? The midpoints of the diagonals. So don't ever bother finding the midpoint of the side of a parallelogram. That doesn't help me. Midpoint of a diagonal does. Lengths of sides. So when we're given information about a parallelogram, first thing, or about a quadrilateral in the plane, and we're asked to prove it's a parallelogram, the first thing we're going to want to do is sketch it. So I know what are my sides and what are my diagonals. All right, here's A, B, C, D. I know, I can tell by looking at it, I'm not going to connect them A, C, B, D. That wouldn't get me what I'm looking for, would it? It would cross over. It wouldn't be a polygon. It has to go around A, B, C, D, or A, D, C, B, C, C, B. Excuse me. A, D, C, B. Once I've established that, then we can prove using any one of those methods, any one of the facts that we have, that it's a parallelogram. And again, ways I can prove it's a parallelogram by showing both sides are both pairs of opposite sides congruent, both pairs of opposite angles congruent, which I can't really do in the coordinate plane, so we're going to throw that one out. Both pairs of opposite sides parallel. One pair of opposite sides both parallel and congruent, or that diagonals bisect each other. And basically in the homework today, you have 4 problems. I expect you to use 4 different methods on those problems. I don't expect you to use the same method all 4 times. I want to see you use all the methods, which requires all the formulas. So let me make that perfectly clear. Can you do 2 problems the same way tonight? No. You have to use a different method each time. And I'm going to demonstrate that for you for this particular quadrilateral. So let's start. Let's start by maybe doing both pairs of opposite sides parallel, because that's our first theorem. So what do? I measure the slope. The slope of AB, and I show my math when I do this. So y minus y over x minus x, 5 minus 3 over 2 minus negative 3. That's 2/5. Good. Now I find the slope of BC. That's the next side. And I show my work. 2 minus 5 over 5 minus 2. That's negative 3/3, or negative 1. Then I find the slope of CD. Notice I'm labeling what I'm finding. Then I show the math of what I'm finding. So the slope of CD would be 0 minus 2 over 0 minus 5. That's negative 2 over negative 5, which is 2/5. Aha, these two are parallel. Find the slope of DA, which would be 3 minus 0 over negative 3 minus 0. Or negative 3 minus 0, positive 3 minus 0 over negative 3 minus 0, which is 3 over negative 3, which is negative 1. Aha, these are parallel. So, both pairs of opposite sides parallel, must be a parallelogram. That's proven. Slope is actually pretty easy. We have to know our formula. We have to be able to subtract with confidence, make sure we put the y's on top, the x's on bottom. But it comes out very quickly. It's very clear that these sides are parallel and these sides are parallel because they have the same slopes. So that'd be one way of doing it. Oops. Actually that was diagonals. We're going to use the diagonals this time. This time, instead of proving lines parallel, I'm going to prove the diagonals bisect each other. So the diagonals are AC and BD. Remember, A is at negative 3, 3. D is at 0, 0. C is at 5, 2. And B is at 2, 5. So I could say midpoint of AC is x plus x, negative 3 plus 5, over 2, y plus y, 3 plus 2, over 2, which would be at 2 over 2, 1, 5 halves. Find the midpoint of the other one, BD. And again, 2 plus 0 over 2, 5 plus 0 over 2. Showing my work, that's 1, 5 halves. Aha, same midpoint, diagonals bisect. Each other. Must be a parallelogram. Right? So I just used two different methods. Now, this is probably the easiest of the four methods because we want to do two calculations. Two midpoints. It works nicely. So there's a second way we could do it. A third way. I'm just off on the ways I'm doing it here. Prove, let's do this one, opposite sides, congruent. No, we did parallel. Parallel and congruent are two different things. So I prove opposite sides congruent, again, labeling my points with coordinates just so I have them available. I'd start finding my distance formula. AB equals square root of, okay, x1 minus x2, so negative 3 minus 2. What? No, this is 5, 2.
Oh, okay.
This is 2, 5, yeah. So AB would be negative 3 minus 2 squared, 3 minus plus 3 minus 5 squared. So it's negative 5 squared plus negative 2 squared. So that's, what's negative 5 squared? Positive 25. Negative 2 squared is positive 4, so that's the square root of 29. That's AB. Now maybe go on to BC. For BC, my x's are 2 and 5. My y's are 5 and 2. That's negative 3 squared plus 3 squared is the square root of 9 plus 9, or the square root of 18. I don't need to simplify that because we're just going to find the other one anyway. It's the square root of 18. We're good. Now I go on for CD. CD, the x's are 5 and 0, the y's are 2 and 0. The square root of 5 squared plus 2 squared, 25 plus 4, square root of 29. Aha. Those are congruent, aren't they? Then we do DA. Which would be negative 3 and 0 and 3 and 0. That's negative 3 squared plus 3 squared is the square root of 9 plus 9, square root of 18. These two are congruent. Both pairs of opposite sides are congruent. That's a parallelogram. Distance formula takes a little longer, but we can do it. That's 3 different ways now that I've proven that it's a parallelogram. Some require a little bit more math, some require a little less math, but nonetheless, we can do them. Slopes of all 4 sides, midpoints of both diagonals, lengths of all 4 sides. Well, actually, I'll leave that up there. Prove, let's do it this way. Yeah, I'm going to leave it up here. Prove 1 pair of sides congruent and parallel. So this is just a mix now. I'll pick 1 pair of sides and do congruent and parallel. So I'll measure distance and slope for 1 pair of sides. So again, 0, 0, 5, 2, 2, 5, negative 3, 3. And you can pick either pair. Let's pick AB and CD. So slope of AB, we've already done this. Y minus y, 5 minus 3, over x minus x, 2 minus negative 3. That's 2/5. Slope of CD, 5 minus, or 2 minus 0 or 5 minus 0 is 2/5. Aha, these are parallel. And I can find the length of AB. Again, distance formula. Notice again how I set that up. I put all the symbols in first. To make sure I got the symbols right, then I put my points in. X's are negative 3 and 2. Y's are 3 and 5. So negative 5 squared plus negative 2 squared. 25 plus 4 square root of 29. And CD, 5 minus 0 squared plus 2 minus 0 squared. 25 plus 4 square root of 29. They're congruent. So AB and CD are both parallel and congruent. Okay, so just using those methods, we just keep using distance, slope, midpoint formula. And those are the 4 different methods I want you to be describing. But obviously, know and be able to apply distance, midpoint, and slope formula. Now, it's not hard with parallelograms at all. What gets very difficult in the later half of this unit is, well, okay, we know it's a parallelogram. Maybe it's a special parallelogram. Is it a rectangle? Is it a rhombus? Is it a square? And eventually we're going to get to the point where we're going to need to take at least 6 measurements to determine exactly what kind of shape it is. I mean, right now I know from this it's a parallelogram, but is it a rectangle? Well, as a rectangle, these sides would have to be perpendicular. I'd need to know the other slopes. Okay? Well, here are all the slopes. Is it a rectangle? No, it's not, because these sides are not perpendicular to each other as well, are they? This would have to be 2/5. This would have to be negative 5/2, right? That would make it a rectangle. So if it's not a rectangle, it can't be a square. Is it a rhombus? Are all 4 sides congruent? Now we got to take more distance formula measurements. So we're going to be doing this quite a bit using midpoint and distance formula. It's going to be on your quiz tomorrow, or Thursday, using midpoint and distance formula. So there's a lot of practice required with midpoint and distance formula. But it really comes back to knowing your formulas and knowing how to use them. We've been working with you on that pretty much since the first week of school. At least as far as distance goes, that's for sure. Slope is from last year. Midpoint, not too tough. So we've got our book assignment, which is brief, But I'm also, because we aren't going to have a lot of time to go over the review packet on Thursday, in fact, we're going to have any time in class, because it's a short day, I'm going to give you the review packet to start working on today. It seems long because there's lots and lots of space for some of these problems because there's pictures. I mean, like, the second and third pages here really are very quick. Lots of space. So lots of writing showing your workspace. There's really not even much work to show on those, but, oh, you already have that. That's true. So I'm going to hand out the review packages. Technically aren't due until Thursday, but I'm going to hand them out now so you can start working on them, because we'll be going over questions and stuff tomorrow. Tomorrow's our review day. I want to make sure you're prepared for this benchmark. Retakes, just a reminder, there's still a lot of people who have retakes out there, or who should be asking for retakes because you got a poor grade on something. We're down to about 2.5 weeks left to get retakes in for Unit G, for the last unit. So, yes, it is. I put it in last night. Put it in right after school yesterday. Michaela, your unit test is in there too.